All right, lesson 3, chopping logs. First section is to rewrite the expression with a exponent instead of with a radical. All right, so first one is going to be x to the 1/5 power. Second one's going to be s to the 2/7 power, so that the power on the radicand, the s squared, 2 becomes the numerator, and the root index 7 becomes the denominator. So the next one is w, take the 8, put it over the 3, get w to the 8/3 power. On the next one, I would notice that the third root of 8 times the third root of r to the 6th, that third root of 8 is 2, and then the r is going to become 6 over 3, so the answer is going to be 2r to the 2nd. Same thing happens on the next one. You have the 125 to the 1/5, so not exactly the same thing, and then m to the 5/5. So that m part of it is equal to 1. This 125 right here, 125 is 5 to the 3rd power. So that makes that 5 to the 3/5 power. So that you get 125 to 1/3 becomes 5, sorry, the 1/5 becomes 5 to the 3rd to the 1/5, and 5 to the 3/5. The next one, I would multiply 8x squared out to get cube root of 64x squared. That's 64 to the 1/3 power, x to the 2/3 power. 64 to the 1/3 power is equal to 4, so that's 4x to the 2/3. On number 7, go full screen here. Number 7, this is 9 to the 1/3 power, b to the 8/3 power. 9 is 3 squared to the 1/3 power, b to the 8/3. It becomes 3 to the 2/3 power times b to the 8/3 power. The last one is going to be 75 to the 1/2 power times x to the 6/2 power. 75 is 25 times 3 to the 1/2 power times x to the 3rd, because 6 divided by 2 is 3. And now 25 to the 1/2 power is 5. So it's 5 times 3 to the 1/2 times x to the 3rd. Okay, it's a little tricky there. All right, next section. Again, we're going to use the radical. We're going to make it log in base 3 of 3 to the 1/5 power, which is 1/5 the log of 3 in base 3, which is 1/5, because this part is equal to 1. All right, then the next one is the log of 4 to the 1/3 power in base 2, which is 1/3 the log of 4 in base 2, which is 1/3 times 2, which is 2/3. So the log of 4 in base 2 is equal to 2. The next one will be the log of 343 to the 1/5 power in base 7, which is 1/5 the log of 343 in base 7. The log of 343 in base 7 is equal to 3. That's 1/5 times 3, which is 3/5. And the next one, this is the log of 3,125 to the 1/5 power in base 5, which is 1/5 the log of 3,125 in base 5. And all of these logs that I'm highlighting in yellow are exact values. In this case, this is 3,125 is 5 to the 5th. So this is 1/5 of 5, which is equal to 1. Some tricky ones there. All right, number 15. Ordinarily, the log of x in base 3 would have an x-intercept of 1. You can see 1 right here. You notice this is now translated down by 3. So I would say that this function written below here is the log of x in base 3 minus 3. Now, you can do that without looking necessarily at the graph, because the law of logarithms here is that the log of x over 27 is the log of x, excuse my voice, in base 3 minus the log of 27 in base 3. And again, this is equal to 3. But you can see it on the graph too. Same thing happens on the next one. If you scroll down here, here's where the x-intercept used to be. Now it's up 1. So we'd expect this to be the log. What's the base here? It's still 3. The log of 3x is equal to the log of 3 in base, sorry, backwards. The log of x in base 3 plus 1. And you can see that plus 1 right in there, because this becomes the log of 3 in base 3 plus the log of x in base 3. And again, here's the 1 right there. Right there. Okay, very simple. All right, the next one's a couple of ways to attack these next few. You could go to each one of them and see if you compressed it, if it could become this log of 40 and 40x in base 10. So on the first one, notice those are all pluses. So that can compress to the log of x times 5 times 8 in base 10, and then that gives you the log of 40x in base 10. So definitely A is equivalent. B, you get the log of x in base 10, log of 4 in base 10, and then on the 1 down the end there, that's the log of 10 in base 10. And then compress it together, and you get the log of x times 4 times 10, which is like the log of 40x in base 10. So this one's good too. Part C is no good. You can't just take the 80x and the 2 and divide it. There's no rule that says that the log of 80x in base 10 divided by the log of 2 in base 10 is these two guys divided. So you gotta be careful. That's not the division rule. The division rule states that the log of a division problem becomes the difference in the logs of that. Not that a division problem becomes a compressed logarithm. So on that one, I would say A and B. All right, on number 16, actually, is there something missing? Yeah, actually, number 15, there's another choice. At least there's another choice in the book itself, which is D. And since it's not here, I'm going to assume you don't have it. So I'll leave that one out. All right, number 16, we want to figure out if the log of 3x plus 2 is equal to any one of these down here. So in the case of the first one, choice A, that can become what? The log of 125 in base 5 added to the log of 25x in base 5. So the log of 125 in base 5 is 3. And this one would be the log of 25 in base 5 added to the log of x in base 5. And this is 3 plus 2 plus the log of x in base 5, which is 5 plus the log of x in base 5. So it doesn't look like A is one of our choices here. Okay, we go to, so A is out. B, I think it's going to work. Squeeze it in over here. The log of 75x in base 5 becomes the log of 25 times 3 times x in base 5, which is the log of 25 in base 5 plus the log of 3x. And the log of 25 in base 5 is 2. So yes, this guy here is equivalent to that one right up there. Now in the case of C, which is tough to squeeze in here, on C, we have what? Let me make some room here. Let's see. So we have the log of 9x in base 5 minus the log of 3 in base 5. Now, the next one, 625, is 5 to the 4th power. So that's going to be the log, that's going to be 1/4 the log of 625 in base 5. And the last one is the log of 5 in base 1. So if we look at this term right here is worth what, 3/4? Actually, let me just compress it all together. Let's start it again. Sorry. So I'm just going to take the entire expression and compress it together into one statement. So the 9x I'll put in the numerator. The 3 I'll put in the denominator because it says minus log of 3. The square root of 625 I'll put in the numerator because it says plus that. And then I'll put the 1 in the numerator as well. So I've taken this expression and all the pluses, all the positive ones, the numerator contains those. Then if I play with this, the 3x, the 9x divided by 3 is 3x. The square root of 625 is 25 in base 5. And that's the log of 3x in base 5 added to the log of 25 in base 5. And hence, this one works as well because that's the log of 3x plus 2, which is what we got over here. So C works. And D, I'm going to take pretty much the same approach as I did with C. I'm going to make one single logarithm out of it. So it's the log in base 5. I'm going to set up a quotient bar. So it says log of 50. I'll put that in the numerator. Plus the log of 36x. 36x in the numerator. Minus the log of 4. So that goes down here. Minus the log of 2. So that goes down there. Okay. So I get everybody, the log of 50 is in the numerator. 36 is in the numerator. 4 is in the numerator. I need a 3 in the numerator too for this guy, and a 2. All right, so let's do some canceling here. The 2 divides into the 50 25 times. The 4 times the 3 is 12, so that divides into 36 3 times. So now my numerator is gone, so I have the log of 25 times 3x, which is what I just had in this problem up here. In base 5. So that's log of 25, in base 5 added to log of 3x in base 5. And voila, that's 2 plus log of 3x in base 5. Okay? So I'm compressing the logs back together and then simplifying. All right, number 20. I'm going to write in exponential form. 4 to the 1/2 power equals 2. X1 1/3 to the negative first power equals 3. And X1 2/5 to the third power equals 8 over 125. So this is my rule. If I have the log of A and base B is equal to C, that's equivalent to B to the C is equal to A. And I kind of think of it as coming around the corner like that. So B to the C is equal to A. On the last section, which I don't see, 102. Yes, that's the last section. Okay, so let me just make sure that in, I do this one, actually no, I skipped 17. 18 and 19. My bad. So convert to log form. So this is going to be the log of 512 in base 2 is equal to 9. The next one's going to be the log of 0.01 in base 10 is equal to negative 2. And the last one's going to be the log of 3/2 in base 2/3 is equal to negative 1. All right, so a couple things here. If you have the log of A plus the log of B minus the log of C, that can become a single log of A times B over C. And that's kind of the approach I was taking with the questions. I think it's number 16 and 15. All right, so hopefully that makes sense to you. We'll put an algebraic manipulation here. There you go.